video, we are going to look at numbers. Numbers, basically we are talking about floats and integers. So head over to your VS Code and create a file. We are going to call it numbers. But it's better to pause a minute here. The Python base, or the Python file, or Python files, or Python as a language or as an interpreter has a base class, or base class is called numbers. And therefore, naming our file numbers, it might conflict with the Python base classes of numbers. So we will test out this. And remember, in the previous video, we talked about using inbuilt functions as variable names. And let's see, it is already even complaining from the word go, but seeing this hovering. But let's see. So we want to create a pair of numbers, which we are calling nums. And we are saying this is 2 plus 3. And we want to print nums. Normally we know that we would print this straight away, but we are seeing that the editor is complaining to us, and when you hover over it, seeing these errors, overriding the standard library module numbers. Yes. So there is a standard library module called numbers, and it is conflicting with our name. So we need to edit this. So you can rename and call it number. And now the errors are gone. You don't have to necessarily call this number or numbers. You can choose any other name, but you might be tempted to name it anything close to what you're doing. And in the due course, you're conflicting with inbuilt classes. Okay, so we have numbers, and we know that these are two integers, and when we add them, we expect to get something. And therefore, when we call Python run number, we are getting 5, just something we expected. So those are integers, and we can look at another representation of integers as part of numbers. We can have 2 plus 3 again in brackets times 4, and we can print nums again. So doing that, still we get what we expect. This is 5 times 4, which is 20. We can also talk about floats. Floating numbers. So what are floats? In Python, any number with a decimal point is a float. That's not necessarily true in other languages like C++ and Java. They have other names, but in Python, anything that has a decimal point is a float. For example, we want to look at a float number, which is 0.1 plus 0.1. If we print this number, we expect to have 0.2, and that's what we have here. So those are floats, but maybe we'll talk about division here a little bit. We can say div equals to 4. We talked about the division operator yesterday in the previous videos. And what do you expect here? Pay attention to the result div. We expect the answer to be 2, but when we run, we are getting 2.0. Yeah, it's the same answer, but why are we getting a float? Yet what we have here is not a float. Note, and you need to pay attention to this. In Python, it defaults to a float in any operation that involves a float. Python will automatically default to a floating number as long as in that operation there is a floating variable or a floating number. The result will be a float. But in this case, 2 and 4 are not floats. Yes, even dividing any two numbers in Python result into a float. So those two things are very important. I think that improves some level of precision and some level of accuracy. Well, performance enthusiasts can have debates over that, but that's what we need to know. If, for example, we want to print out some value, P something floating integer equaling to 3.0, we want to demonstrate this defaulting to, let's even square it. This defaulting of Python to floating values. Okay. When you save and run, you see we are getting 9.0, and because we have a floating value, if we remove that float and now we have integers, and this is multiplication sort of, remember we are powering, we get 9. So as long as the operation includes a floating number, the result will default to a floating number. Lastly, or second last, we want to look at the underscores. For example, let's have a value age of Ultron. You've watched Transformers, but the age of Ultron is not this age, but well, it doesn't matter. Python allows us to separate values by using underscores. For example, I can separate that, even that. If you want, you can do even that more. If you print age of Ultron, look at what happens. You get the complete value. That 14 billion, I'm not sure, but that's what you get. So this is not limited to only 3 groups. You can still have maybe val equaling to 1_00, and you want to print your val. Still you get the 1000, and you can still reduce that, still good. You print again, you have 100. So it's important to also note that. Now, one thing we also need to talk about are constants. We see that sometimes we will need the constants, and in Python, what differentiates a constant, it should be in capital letters. At least it's a convention I've seen. So you could be offering a discount in your e-commerce application of 0.1, which is 10% maybe. So we can know that that's a constant. We also have multiple assignments in Python. Multiple assignments. Look at X. Maybe you have coordinates X, Y, Z, and you're giving them 1, 2, and 3. Have space here, which is not good. But I will talk about those spaces in other subsequent videos. Indentation in Python, it is important. So we can print the value of X, print Y, and then print Z or Z. People love calling it Z, especially mathematicians. So we can do multiple assignment, and this is also common in other languages. So that's it for you guys in this video, and if you like the video, don't forget to subscribe and like and leave a comment. I'll see you in the next video.